Mr. Samuels here. Before we start today's lesson on the periodic table, I got a quote of the day. Jim Rohn tells us, if you really want to do something, you'll find a way. If you don't, you'll find an excuse. So think about for a sec what that means to you. For me, I think about it is one thing putting a lot of responsibility on me, right? Like if I didn't do something that I wanted, maybe I didn't really want it that bad. About priorities, right? But also, you can kind of think of it as a power. That if you really want anything, you can find a way if you want it enough. Anyways, let's talk about the periodic table here. Take a look at it. You can see that it's got this kind of peculiar shape, and let's try to kind of look at the way it's organized. You guys know by atomic number, the number of protons, it goes in order, but let's look at some other patterns. One of the patterns you'll see are the columns, that's the up and down. Those are called groups, sometimes called families. And the periods are the left and right on the periodic table. Those are the rows. So make sure you keep that periodic table in front of you so you can reference as we talk about these. And ask yourself, which one do you think has similar properties? The families or the rows? Hey, the families, just like your family, will have some similarities. Let's take a look at number 29, copper. Take a minute to find that. It's in the 11th group. Okay. Go down below copper and you see Ag. That's silver. And under that, Au, gold. Interesting. Gold, silver, and bronze. Hey, look, it's like the metals. Those things have definitely something in common. So it is actually the elements in the same group or family that have similar properties. Take a look at group 17 as well. On the right of the periodic table, you'll see fluorine. Think about what we're going to find that at the dentist. Why do they put that in your mouth? Oh yeah, and it's in toothpaste because it cleans your teeth by killing the bacteria that cause damage. Underneath that, chlorine. You find that in pools, bleaches, etc. because it kills bacteria. Near the bottom, iodine, number 53. That's the brownish yellowish stuff they put on you before surgery because it kills bacteria. And if you had to guess what bromine, number 35, does, that's right, you called it. It kills bacteria. So those are in the same family, and that family actually has a name. It's called the halogens. So let's look at some of these family names. The first family I want you to talk about is group 1, far left side, not including hydrogen, starting with lithium, then sodium, potassium, etc. That first column, these are the alkali metals. They have some things in common. They're all soft. You can cut these metals when they're in their pure states with a butter knife. And they're also very reactive. Some of them near the bottom actually react explosively with air. So you're not going to find them by themselves, but certainly in compounds. Stuff like sodium and potassium, obviously you're not going to eat them in their metallic form. They've already reacted with other elements to form new compounds that aren't so reactive by the time they enter your body. Second group there, alkaline earth metals, beryllium, magnesium, calcium, etc. Those react with water, but not as extremely. And you'll notice, too, some similarities. Calcium and magnesium are both essential minerals you need to survive. Now, the middle block here, 3 through 12, this is a huge group called the transition metals. They're all so similar. It's like one big happy family. Lots of cousins and aunts and uncles and everything. You'll see gold, silver, platinum, nickel, iron. They're all very similar. What they have in common is they're less reactive. That's why it's better to build a car out of iron than out of sodium, for example, just because it'll last longer. And when they react with other elements, they formed really neat colored compounds, whereas most of the compounds these guys form in the first two families are white. Group 17, we talked about them, the halogens. They react with metals, they kill bacteria as we mentioned, and they form acids when they combine with hydrogen. You may have heard of, for example, hydrochloric acid. And sorry, this is hard to see at the bottom. Group 18 is called the noble gases. The noble gases, if you notice, they're all in red on my big periodic table. And they don't react with other elements. They don't form compounds. They're too noble to mingle with the commoners, I suppose. Okay, so there's some other things on the periodic table going on. If you're taking chemistry for honors credit, make sure you know that the stuff on this little staircase here for groups 13 through 16 there, these elements that are touching it are called the semimetals or metalloids. That staircase divides the metals from the nonmetals. So elements on the staircase have properties kind of both. All right, the bottom rows, very, very bottom, 58 through 71, these are the lanthanides, and then 90 through 103, these are the actinides down there at the bottom. Notice, these are metals, but anything past uranium, notice how on my periodic table on the wall they're clear. That's because they're unstable. Think about it. 93 protons, all those positive charges are going to try to repel each other and break apart into smaller elements. So you don't find those in nature. They're only made in the laboratory. Some of them, like americium-95, will last for a good 7 years. But then other stuff, when you get past 100, some of these elements, since they're so unstable, they only last in the laboratory for a matter of seconds. So that's what I was talking about. Lanthanide, here's the actinides, alkali metals, alkaline earth transition. Think about this here, this staircase. We don't have family names for these guys. It's kind of like a mixed family. My own family has a couple different last names because, we have different people getting married later in life, etc. So you remember, honors, these are called the metalloids, but these might just be other metals or other nonmetals. Okay. Next thing I need to teach you about is the size of these atoms when they're in their neutral form. As you move to the right, you'll see the size decreases. They get smaller, generally. So what that means is that a lithium atom is bigger than a beryllium atom, even though beryllium is heavier. Okay, make sure you keep looking at the periodic table to get these. As we go down the chemical families or the groups, you'll notice as you go to the bottom, they actually get bigger. So potassium, K, is bigger than sodium, Na, for example. And that's what I mean by that. Okay? So as we move to the right, they get smaller. As you move to the bottom, they get bigger. So bottom left are your biggest boys, top right are your teensy-tiny ones. And that's the general trends on the periodic table. Thank you for listening.